The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, just a couple of comments about your test. So if you have specific questions that you would like me to look at with you, come during my office hour or email me. I'm not going to use regular class time to deal with that, but if you do want me to go over any of those questions with you, contact me. Like I say, either show up for the office hour or email me and I will contact you. Another comment I want to make, two of you took the final exam as opposed to the chapter, the objective one test. All I can say is I guess you need to read more carefully as to what the titles of things are. But anyway, enough about that. Today we're going to go on to cover objective 2.A, or not 2.A, but 2A. So let's go ahead and get started. So we're going to deal with fractions, decimals, and percents. Okay, and we're going to look at how to convert from each of these to each of the others of those. We're going to start with converting fractions into decimals. Okay, so we're going to go from fractions to decimals. All right. So basically, to convert a fraction to a decimal, you use long division. Let's say we have the following fraction, 4/5. Well, 4/5 is equivalent to 4 divided by 5. So we can take 4 divided by 5. When we divide, and we're going to have to go, we're going to get answers that include decimals and everything, we keep in mind that 4 is the same thing as 4.0 or 4.000 or however far we need to go. But when we start out here, we've got 5 does not go into 4. Therefore, we have to extend 4 and make it 4.0, and we'll see how far we have to go with it. Also, if there is a whole number outside, then things are good to go. And on the inside, the decimal point moves straight up in the answer. Okay. So 4 divided by 5. 5 doesn't go into 4. Well, we'll say it goes in 0 times. 5 goes into 40. How many times? 8. And 5 times 8 is 40. And we subtract, we get 0. So this is an exact answer. So 4/5 equals 0.8 as a decimal number. Any questions about that particular example? All right, let's take a look at another one. Let's say we've got 7/8, and we want to convert that into a decimal. So we'll take 7 divided by 8. Using long division. 8 does not go into 7, so we'll put a decimal point, add a 0, we'll move the decimal point straight up above, and proceed to divide. 8 times, let's see, 8 times 5 is 40, 8 times 8 is 64, 8 times 9 is 72, so 8 times 8 is 64. We'll subtract, 70 minus 64 is 6. Okay, 8 doesn't go into 6, so that means we've done it correctly because we want this to be smaller than that, right? Okay, so now I'm going to add another 0 and bring it down. 8 goes into 60. Let's see, well, 8 times 8 was 64. That's too big. 8 times 7 is 56. So we're going to subtract that. 60 minus 56 is 4, but 8 doesn't go into 4 and it doesn't come out exact, so we'll add another 0 and bring it down. 8 goes into 40 exactly 5 times. So there's our answer. So 7/8 equals 0.875 as a decimal number. Any questions about this example? All right, let's say we've got the following. 2/3. And we want to convert this into a decimal number. So 2 divided by 3. 3 doesn't go into 2, so we'll add a decimal point and a 0 and take the decimal point and move it straight up. 3 goes into 20. Let's see, 3 times 7 is 21. 3 times 6 is 18. 20 minus 18 is 2. 3 doesn't go into 2, so we'll add a 0 and bring it down. Let's see. Oh, I should have put a 0 there to start with because 3 doesn't go into 2. 3 goes into 20. 6 times 18. 20 minus 18 is 2. And we keep going and we start to see that what's happening here. These 6s are repeating. So basically, we only need one of those 6s to imply that it's repeating. So 2/3 would be 0.6, and we put what's called a repeating bar above the 6, which implies that that 6 continues to repeat. We could just do this thing forever and ever, and it would keep going on and on. Now, one of the things we need to be careful of, there's not only the arithmetic part of these problems, but it's entering it into WAMAP correctly, okay? So here we have a repeating decimal, and I want to look at some of the language that it uses. So I'm going to look at a problem in WAMAP. So hang on here, let me do that. See here where it says question number 3, convert the following fraction 1/5 to its decimal, to its equivalent decimal value, all right? So there's a terminating decimal. That would be like the first 2 examples where we had 0.8 and 0.875. That would be a terminating decimal, okay? Then there's what's called a repeating decimal. That's like the problem we just did, where we've got 0.6, and then that 6 just continues to repeat. And then there's a partial repeating decimal where after the decimal point, you have a number or 2 or 3 or whatever, but then after that, there's a single digit that continues to repeat. So for instance, in problem 3, what you have to do 2 things. First of all, you have to identify what kind of decimal it is, and then put in the answer. Let's go ahead and let's do problem number 3. So let me take the 1/5, and we'll go back to my whiteboard. I can find my mouse here. Okay. So 1/5, 1 divided by 5. 1 doesn't go into 5, so it goes in 0 times. We'll add a 0. Notice the decimal point went straight up. 5 goes into 10 twice, and it goes in exactly. So 1/5 is 0.2. This is a terminating decimal. It doesn't continue to repeat. So now let's go back to our WebAssign, WAMAP. I'm using both of those this quarter in different classes. So this is a terminating decimal. So I'm going to click on that. And then down here, I'm going to put in 0, and there's the decimal point, 2. Okay. You notice it said submit all parts. So you don't want to just put in the answer here. You want to choose what kind of a decimal number it is, terminating or repeating, or a partial repeating decimal. Do you have any questions about that particular situation? Again, I just say be sure to read all of the information in the problems on WAMAP, because there are certain ways you have to put certain things into the problem. For instance, let's go down to, let's see, I think it was problem number 17. Okay. So here it tells you, let's say you're going to put an answer in that is a repeating decimal. it tells you how you're supposed to do that in WAMAP. So we don't have a way to put a repeating bar above a number. So for instance, 0.5 with the 5 repeating, you would write point or just a 0 point, and then the word bar, and then parentheses about around the number that you want to repeat. And I know that's a little bit awkward, but I think you'll get used to it. Again, follow the directions that are given below each problem if there are specific directions. Any questions about that? All right, well, let's go back to the whiteboard then and continue with some problems converting fractions into decimals. Let's say we've got 2/9. Okay, so 2 divided by 9. 9 doesn't go into 2, at least not a whole time. So we're going to add a decimal point and bring it straight up. And then we'll have a 0 here. 9 goes into 20 2 times. 2 times 9 is 18. We'll subtract that from above. 20 minus 18 is 2. 9 doesn't go into 2. So we'll add a 0 and bring it down. 9 goes into 20. 2 times, we get an 18. We get a remainder of 2. Can you see what's going on here? We're getting 0.2 repeating. Okay. So 2/9 equals 0.2 repeating. And in WebAssign, we would write point and then the word, whoops, hang on here, sorry. So we put a 0, a decimal point, and then the word bar, and then in parentheses, the 2. So that's how in WAMAP we enter this number, okay? If you were taking a test and using paper and turning in your paper, in a regular classroom, you'd write the answer like this. But for WAMAP to recognize it, you have to use that notation. All right, let's see here. How about a mixed number converted into a decimal? Well, I want to look at 2 ways of doing this. First of all, we're going to do it the long way. It's not the wrong way, it's just the long way. What we could do to convert a mixed number into a decimal, first of all, we could change it into an improper fraction. 2 times 2 is 4, plus 1 is 5, divided by 2, so we get 5/2. Any questions how we converted the mixed number into an improper fraction? All right. Then we take 5 divided by 2. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. Okay. But we're going to keep going with it. So we're going to add a decimal point and bring down the 0. 2 goes into 10 5 times. Exactly. So 5/2, which was 2.5. Oops. Equals 2.5. I want to point out that in 2.5, 2 is the whole number, 1/2 is the partial number or the fraction. Our answer in decimal form, 2 is the whole number and 0.5 is our decimal part of this final answer of 2.5. Okay, so the whole number parts are the same. Now, what does that mean? It means that we could have done this. Instead of converting it into an improper fraction, we could have said, well, the 2 is still going to be 2, and the 1/2 we're going to convert into a decimal. So we can just take the 1/2 and say, well, 1 divided by 2 goes in, oh, not 2 times, slow down, goes in 5 times. So we get 2 plus the 0.5 and we get 2.5. So in other words, if you want to change it to an improper fraction and then change it to a decimal, you can. If you've got a mixed number, you can take the whole number part and that will be part of your final answer and just take the fraction part and convert it. Now, you might say, gee, I don't know why I would want to do this. It doesn't seem that big of a deal to do it this way, and that's great. But what if you had something like this, 100,413 and 2/5? Would you want to change that into an improper fraction? No, because you could go over here and say, well, it's going to be 100,413, and then take the 2/5 oops, which is going to be 0.4. Okay, so either way is fine. If you're most comfortable just continuing to do it that way, that's fine. Okay, let's see. Let's take a look at converting an improper fraction to a decimal. We did a fraction, we did a mixed number. Let's take, how about 17 fifths? So basically this could have been a mixed number and we would have converted it into an improper fraction, but it's already an improper fraction. So what do we got? We've got 17 divided by 5. 5 goes into 17 3 times. 17 minus 15 is 2. So I'm going to add a decimal point, bring down a 0. 5 goes into 20 4 times. That goes in exact. So 17 fifths is 3.4, which is a terminating decimal. All right, so that's converting fractions, proper or improper, or mixed numbers into a decimal. So in all those cases, we use long division to convert. Do you need any more examples of that before I go on to the next idea? All right, so now we're going to go the other direction. We're going to convert decimals into fractions or mixed numbers. So let's say I have the following. I have, let's go with 0.7. Okay. Now, there are a couple of ways of doing this. The easiest way would be to look at the name of the last digit at the right. Okay. So the 0 is in the ones column. The 7 is in the tenths column. Okay. Remember from the previous information where we talked about placeholders. So if we were to say this out loud, we could say 0.7, but really the technically correct way of saying this would be 7 tenths, because there is a 7 in the tenths column. Well, if I say the name 7 tenths, but I write it as a fraction, it would be 7 tenths. Okay, so 0.7 or 7 tenths as a decimal is 7 tenths as a fraction. Any questions about how I got there? Okay, let's say we have this 0.13. Okay, well, the correct name for it, you have what, 13, and what's the name of the last placeholder to the right? Hundredths. So this is 13 hundredths. Oops, hundredths. Okay, any questions about that? Let's say you've got 4.728. Okay, well, let's see. This is the ones, the tenths, the hundredths, the thousandths. Okay, so this would be 4728 thousandths. Now, unlike the first two examples here, this one could be converted into a mixed number and also simplified. So how would we convert that into a mixed number? Well, if we took, let's see here, I'm going to run out of room. I'm going to rewrite this problem on the next page. So this is 4,728 thousandths. I could take 4,728 divided by 1,000. Okay. And that would go in what, 4 times? 728. Now, in this case, recall we're changing it from a decimal to a fraction or a mixed number. So I would have 4 and 728 thousandths. Now, I can reduce that fraction part of the mixed number answer. How can I reduce that? Well, what goes into both 1,000 and 728. Aren't they both even? So 2 would go in. Well, let's see. If we divide the top and the bottom by 2, what's half of 728? And yes, I'm going to use my calculator. And yes, you can use your calculator. 728 divided by 2 is 364. 1,000 divided by 2 is 500. But 364 is even. So we can divide that by 2 and get 182. 182. And that, I still didn't write it very well. How about this? 182, but 500 divided by 2 is 250. Wow, it's still even. 182 divided by 2 is 91. 250 divided by 2 is 125. Well, 2 doesn't go into either of those, or does it? What goes into 125? Let's see. 2 doesn't go in. Does 3 go in? Let's see. It goes in 4. That's 12, 0, 5. No, 3 doesn't go in. What goes into 125? 5 goes in, doesn't it? So 125 is like 5 times 5 times 5. Oh, here we go with that prime factoring. 91. Is 91 prime? Does 2 go in? No, because it's not even. Does 3 go in? No, 9 plus 1 is 10. 3 doesn't go into 10. Does 5 go in? Well, 91 is not prime. 7 goes into it 13 times, but 5 doesn't go into it, and the denominator is just 5s, so this thing isn't going to reduce. So that took a while, but that's our final answer. Oh, no, it's not. It's 4 and all of that, isn't it? That was just our remainder. So 4 and 91 over 125. Wow, that was a lot of work, wasn't it? Fun times. Okay, now let's go back and let's look at another way of doing, let's see here, these. And just to give you an alternative approach, and then you can go whichever way you want. Okay, so let's take these same problems. Gotta be careful to just erase what I want to erase. Instead of saying, well, it's 7/10 and getting right to a fraction, which is probably the easiest way, we could do this. We could say, what do we need to do to get rid of that decimal point? What do we need to multiply by? Well, if you multiply by 10, you move the decimal point 1 place. So that would give us 7 on top, because it moved the decimal point 1 place. But if we multiply the numerator of a fraction by 10, we have to multiply the denominator of a fraction by 10. And there we have the same answer, 7/10. More work to get there, but it works, okay? So now what about this next one? Well, we'd have to multiply by 100, by 10 times 10 to move the decimal point over 2 places. So we'd multiply the bottom by 10 times 10 or 100, and this would give us 13 over 100. So again, you could do it this way, but it's still easier just to look at the placeholder name and say, well, it's tenths, hundredths, it's 1300ths, bingo, it's 1300ths. And then this one, you've got what? Tenths, hundredths, thousandths. So you'd multiply this way and you'd get 4728 over 1,000. And I won't drag you through all of that stuff that we did here a little while ago to get to that final answer. But the point is, you can either go with the name of it, which will get you directly here, or you can figure out, what do I need to multiply the top and the bottom by to get rid of the decimal point? Okay. Any questions about that? All right. Now let's talk about percents. But before we do, oh, actually, there is one other thing I wanted to talk about before we do. So we talked about how, let's see here. If I have a decimal that's 2 digits to the right, or there's two decimal places to the right of the decimal point, I'd have to multiply by 10 times 10 or 100 to get that decimal point to disappear, so to speak. Okay. Now, multiplying by 10 gets rid of the decimal point, right? Moving it one place. What does dividing by 10 do? Let's say I've got 750 and I divide that by 10. Well, that moves the decimal point one place to the left. Or if I had 43.2 divided by 10, I'd move the decimal point one place to the left. What if I had 43.2 divided by 100? I'd move the decimal point 2 places to the left. So multiplying by 10 moves the decimal point one place to the right. Multiplying by 100 moves it 2 places to the right, by 1,000, 3 places to the right. Dividing by 10 moves it 1 place to the left. Dividing by 100 moves it 2 places to the left. Dividing by 1,000 moves it 3 places to the left. Okay. The number of zeros in the divisor tells you how many places you move it to the left. Okay, any questions about that? Now, there's an idea that we're going to look at later, but I want to introduce it today because I think it's one of the easiest ways to deal with percents. And so, first of all, would you agree that 1 is equal to 7 divided by 7? A number divided by itself other than 0 divided by 0 equals 1. Is everybody okay with that, that 1 equals 7 divided by 7? We okay with that? Okay. Would you agree that 1 equals 7 divided by 3 plus 4, since 3 plus 4 is equal to 7? It doesn't look like 7, but it is equal to 7. Would you agree that that's true? And if you're not seeing any of this, please say, wait a minute, I don't get what you're doing there. Okay. So are we all right with that? So a number divided by an equivalent number equals 1, as long as it's not 0 divided by itself. Okay. What about this? Is 1 foot equal to 12 inches? Is that true? Anybody? One?
Yes.
Yes, it is. Okay. So would 1 foot divided by 1 foot equal 1?
Yes.
Great. Okay. Would 12 inches divided by 12 inches equal 1?
Yes.
Would 1 foot divided by 12 inches equal 1?
Yes.
Would 12 inches divided by 1 foot equal 1?
Yes.
Excellent. Everybody okay with that? All right, now we're going to take that concept and deal with percents. If I eat 1 candy bar, an entire candy bar, what percent of the candy bar do I eat?
1.
1%?
100%.
100%. There you go. So the number 1 is equal to 100%. Okay. Now, 100% equals 100 per 100. In other words, percent could be changed into per 100. Well, what's 100 divided by 100?
1.
1.
1.
Right, good. So 100% is like 100 per 100. In fact, I don't think it's a coincidence that if you take the percent symbol and you look at that and say, oh, you know what? I've got 2 zeros and I've got a 1. Oh, there's 100. I don't know if that's true, but I'm pretty sure. Okay. All right. Now, if 1 is equal to 100%, what would 100% over 1 equal? That's a
1
number. What?
would equal 1.
Right. What would 1 over 100% equal as a number?
1.
1. Okay. These are called unit conversion factors. And we'll talk a lot more about that when we get into where we're dealing with converting different units like inches to feet and seconds to minutes and all of that stuff. But for right now, we're going to use these two unit conversion factors. A factor is something you multiply. Conversion is something you change. We've been converting what? Decimals and fractions to decimals. We're going to be converting percents into regular numbers and regular numbers into percents, but we're going to use these. Okay. And there are many methods of doing this. This is just one of them, but I want to start with this. So let's say I've got 70%. Okay. And I want to change that into a regular number. What do I need to get rid of? I need to get rid of the percent sign, but I can't just go in and cross it out. Okay. I've got to get rid of it through legitimate means. Isn't 70% equal to 70% over 1? Is there an implied 1 that I can put there? Does that bother anybody? Okay, so what do I need to get rid of? I need to get rid of the percent sign. Well, let's go back here. We've got these two options, okay? If I use this, that's not going to work. I'm going to have percent times percent. That's percent squared. I'm not even sure what that is, okay? But what if I use this? What if I multiply by 1 over 100%? I now can reduce out the percent sign units. Okay. And what do I have? I have 70 per 100. Okay. 70 per 100 or 70 hundredths. I'm not done with this problem, but do you see what I did? Do you see how using this got rid of the percent sign? It also introduced dividing by 100, which could be further reduced down to 7/10, right? Okay, are we all right with that? Any questions there? All right, let's take 70% and let's convert it to a decimal. Well, I'm going to do this same thing. Okay. But recall a little while ago, we talked about multiplying and dividing by multiples of 10. Dividing by 100, right now there's an implied decimal point right there. Dividing by 100 would move it 2 places to the left. So 70% is 7/10. You okay with that? Any questions there? Okay. How about 234%? I want to convert this into a decimal number. So I'm going to multiply by 1 over 100%. That will get rid of the percent sign. So now I've got 234 over 100. But dividing by 100 would move the decimal point 2 places to the left. So I've got 2.34. So 234% is 2.34. Let's do a quick check. we said that 100% was 1. So 200% would be 2, and 300% would be 3. Well, this number is between 200 and 300%. So this number should be between 2 and 3. Is it? Yes, it is. You okay with that? All right. Let's take, let's see here. 0.69. That is a decimal number. And I want to convert it to a percent. So it's got to be over implied 1. Now, if I use the same unit conversion factor I've been doing before, that's not going to work because that's going to give me something over percent. The percent needs to be up on top. So now I'm going to use this one because that has the percent on top. Okay, you see what I'm doing there? To get rid of the percent, I got to multiply by a percent on the bottom so they cross out. To introduce a percent, I've got to multiply with the percent on top. Okay, well, let's see, 0.69 times 100. 100 is 10 times 10, so I'm going to move the decimal point 1, 2 places to the right, and I get 69 over 1%, or just 69%. Don't forget the percent sign, right? Because I didn't get rid of it, I introduced it. So 0.69 is 69%. Any questions about that? Okay, let's see here. Let's take a mixed number and change it into a percent. I don't have a percent sign yet, so I'm going to introduce one on top. But I can't really take 2 3/4 times 100. So what am I going to have to do to my mixed number? I'm going to have to change it either
a proper fraction.
Right, or a decimal. So let's say that they want a percent that's written as a fraction or a mixed number percent, that it specifies, write your answer as a fraction or mixed number percent. Okay, so let's see. 2 times 4 is 8 plus 3 is 11/4 times 100% over 1. Are you okay with how I converted the mixed number into the improper fraction? Okay. Well, now I can pre-reduce. 100 divided by 4 would be 25 over 1. Okay with that? So now, let's see, my denominator is 1. My numerator is 25 times 11, which is 25, 25, 275. And 275, percent, right? Don't forget the percent. Over 1 is just 275%. So 2 3/4 is 275%. All right. We okay with that one?
Are we on the tests or the homework gonna have to show our work to you like this? Because if you automatically think about it and just do it, or do we need to break it down on paper like this?
If you can automatically think about it and do it, that's great. Just do it. And the thing is, so let me tell you where I'm coming from today, okay? I looked at a video the other day where they were trying to teach me something, and they showed me about 57 different ways of doing something right off the bat. And I thought, this is crazy. I need to practice one way or 2 ways, but all these different things they told me was too much information. So I'm trying to do that with you, and that is not give you too much information, in that there are a variety of ways you can do this, okay? There's move the decimal point and get rid of the percent sign, move the decimal point and add the percent sign. There's, there's percent is per 100. There's this method. I'm using this method to start with because I think it's the easiest one to grasp. Now, it may not be the quickest one to do, but I think it's the easiest one to grasp. So for instance, if you know that 0.7 is 70%, then go for it. Okay. Or is it 70%? Yes, it is. Because 1.7 would be what, 170%? Well, how are you getting there? Well, you're moving the decimal point 2 places to the right and adding a percent sign. And you probably learned that, didn't you? Whoever it was.
Yeah.
Yeah. So I'm not saying you can't do that. I'm, for the sake of time and all this, I'm starting with one that's like, yeah, this will work. This will get you there. All you have to remember that's new is you use one of these. This introduces percent, this gets rid of it. Now, as far as shortcuts go, absolutely. So let's say I've got 2.75. Okay, that would be 275%. How did I get there? Move the decimal point 2 places to the right and add a percent sign. Let's do it the method I've been explaining. Okay, multiplying by 100% over 1. Well, what does the 100 do? It moves the decimal point 2 places to the right, and then you add a percent sign. So basically, when you're using the shortcut, you're still doing this, you're just not formally writing it. Does that make sense? Apparently not. Did I lose everybody there?
Makes sense.
You're okay? All right. What about going the other direction? What about 75%? Well, if you multiply by 1 over 100%, what does that do? Well, the 100 moves the decimal point 2 places to the left, and you get rid of the percent. So 75% is 0.75. So the shortcut is to convert a decimal to a percent. You move the decimal point 2 places to the right and add a percent. To move a percent to a decimal, you move the decimal point 2 places to the left and get rid of the percent. And if you memorize those rules, that's great. But if you forget them, you can always go back to this and reconfirm how to do that. Does that make sense?
Yes.
Okay, I'm glad somebody's still with me there. Everyone else has gone back to bed on this wonderful Monday. Okay, there's something else I wanted to mention about. Oh, I know what it is. So find it here. It was here a minute ago. Well, I'll just write it. So in the instructions in WAMAP, at one particular place, I saw where, let's say my answer is a mixed number. It says to write it 2 and then have a space, and then you've got your fraction. I tried it with and without the space, and both of them seemed to work. So I'm not sure if I was just lucky or what, but to write 2 3/4 as an answer, it's saying put a 2, then put a little space bar, and then you're going to use your fraction thing that shows up and put your 3 and your 4 in there. Okay, and it was in the instructions, but I'm not finding it right now for some reason. So anyway, I want to look at another example out of WAMAP. And I'm going to use the information given on problem 24, but I'm not going to use the same question. It says, based on Julio's monthly budget, what percent is budgeted for food? Well, let's say that they wanted to know what percent is budgeted for housing. Okay, so percent budgeted for housing. So housing is $600. Oops, I'll put a comma there, my bad. But that's $600 out of what? Out of the total budget, which is $1,855. So you could say, what fraction is the budget? And it would be 600 out of $1,855. But they want to know what percent it is. So to convert this into a percent, we're going to multiply by 100% over 1. Okay. Now, I can get rid of the common units of dollar signs. Okay. In the numerator, I've got 600 times 100. So multiplying by 100, I'm going to add 2 zeros. And in the denominator, I'm going to get this, but that is a percent, right? You still with me?
Mr. Mayo,
Yes.
are you doing this on the whiteboard? Because
I'm sorry. Yes, my bad. Yeah,
Thank
I forgot to go back to the whiteboard. Thank you. So you guys have to keep me honest here. Okay, do you see it now?
Yeah.
Sorry about that. Yeah, so we've got the $600 out of the total budget times 100% over 1. I got rid of the dollar signs. 600 times 160,000 over 1855. Now, back on the WAMAT page, it said round to the nearest 1/10 of a percent if necessary. So that tells me we're going to go with a decimal answer. Let me go back there really quickly. So right here, the instructions, round to a nearest 1/10 of a percent. Okay. All right. So how am I going to change that into a decimal percent? Long division. 60,000 divided by 1855. Wow, let's see here. Where's the decimal point? Right there, right? 1855, no, that's not the year I was born. It was 1856. It doesn't go into 6 or 60 or 600, but it does go into 6,000. What about 3 times? So 3 times 5 is 15, carry the 1. 3 times 5 is 15, plus 1 is 16, carry the 1. 3 times 8 is 24, plus 1 is 25, carry the 2. 3 times 1 is 3, plus 2 is 5. Okay. And then subtracting, I'm going to get that. Bring down a 0. Let's see. I think that's going to go in twice. 2 times 5 is 10, carry the 1. 2 times 5 is 10, plus 1 is 11, carry the 1. 2 times 8 is 16, plus 1, 17, carry the 1, 2, 3. Okay, subtract. What is that? That's a 4. That's a 6. Okay. Now, it said round to the nearest 1/10 of a percent if necessary. And this is a percent already. So where do I need to go to round to a 1/10 of a percent? I'd need to go out to the 100th of a percent place, because you go one place past where you're going to round. Okay, so I got to keep going. Let's see, 1855 into 6400 goes in, let's see, three times again. And that was 5565. So that's gonna, let's see here. I'm gonna use my calculator. 6400 minus 5565 is 835. We'll bring down the 0. I wish I could make this thing scroll up and have more room there. How many times does 1855 go into 8350? Let's see. 8350 divided by 1855. It goes in 4 times. Okay. 4 times 8350 is hang on here. Timeout. I got myself confused because I ran out of room. Well, actually, you know what? That's as far as we have to go, isn't it? Because the 4 would round what? Down. So we get 32.3%. Second here. Yeah. Okay with that? And I know once again, I threw a lot at you today. Let me just recap really quickly. To convert from a fraction or a mixed number into a decimal, use long division. To convert from a decimal to a fraction or a mixed number, you can convert it into a fraction if you know the name of the decimal using the column that's the furthest to the right. To convert to a percent, multiply by 100% over 1. To convert from a percent, multiply by 1 over 100%. Then, of course, you've got all that simplification in the middle. All righty. So for tonight, you've got, what is it? Objective 2A, I believe, is the name of this one. Remember, we've got objectives and outcomes, and this is an objective. So objective 2A for tonight. I will be back at 1:15 with an office hour if you have any questions. Otherwise, have a great rest of the day, and I'll see you tomorrow. Thanks a lot. I'm going to stop the recording.